Yeah, we're already doing it. Hi, it's Miss Murphy. We're back. Okay, quick look at something, theoretical yield and percent yield. There's one practice problem to go with this idea, and I have just attached it to Google Classroom, so hopefully you have that with you. Periodic table, let me get mine, and calculator, let me get mine. All right, so we're gonna look at this simple idea of percent yield and theoretical yield, and obviously it's in relation to stoichiometry. So we'll do some stoichiometry at the same time. Okay, let's go. Let me share my screen here. All right. So I've got here my practice problem, and I have provided you with the practice problem so that you would not need to write it all down. Let us read this problem. Solid silver chromate forms. Okay, so that tells me it is a product, right? When, let me get a different color here. When potassium chromate is added to a solution containing 0.500 grams of silver nitrate. So I can see right now that potassium chromate is added to silver nitrate. So let's go ahead and write that down. Potassium chromate, that's going to be K2CrO4. That is a solid. It is added to a solution of silver nitrate, that's AgNO3 aqueous, because it's a solution. Oh, my head is in your way. Determine the theoretical yield when silver chromate. So let's look, what will we get here? Balanced chem equation. I will get potassium nitrate. That will be aqueous because I know my solubility rules. And the silver Ag2CrO4 will be a solid. We need to make sure our equation is balanced. Therefore, I need a 2 here and a 2 here. All right. Oops, excuse me. All right, let's go back in and start pulling out our questions and data. We've got 0.500 grams of silver nitrate. Okay. Determine the theoretical yield of silver chromate. Calculate the percent yield if the reaction yields 0.5. Okay. Okay, so what is new here is we are given information about silver nitrate, and we are asked about information about silver chromate. We need to know the theoretical yield. All right, so let's talk about what do they mean by the theoretical yield. The theoretical yield is the maximum possible amount that can be produced, right? It is the answer to the stoichiometry problem. Let me make that bigger again. So every time you solve a stoichiometry problem and you say, I have this much, I can make this much, you are getting the theoretical yield. Theoretically, based on the amount of reactant I'm using, I should be able to obtain a certain amount of product, right? Right? Theoretically, if you use 6 hot dog buns and 6 hot dogs, you should get 6 complete hot dogs with buns. However, maybe one is molded. Maybe you drop one on the floor. Maybe it falls in the sink and it gets wet. So what has just happened is you didn't actually get to make all 6 hot dogs because you lost some of your reactants. So what we can then do is we can determine, well, what is our percent, oops, spelled that wrong, percent yield. And we would simply take our actual yield. Let me scoot this over so that I can define it a little bit over here. Okay, I would take my actual yield and I will divide it by my theoretical yield. And then I will multiply that by 100 to turn it into a percentage, right? So the actual yield, you must actually run the experiment. You need to actually get some potassium chromate, some silver nitrate, particularly 0.500 grams of it. You should collect your precipitate, filter, rinse, wash, dry your precipitate, and mass it. The mass that you get will be your actual yield, right? So your actual yield must be determined experimentally. So if you're doing a word problem, it would be provided to you. Otherwise, you would be in the lab and you would have to figure it out. Okay, that's not a very good color. I apologize. I'll get a different one. The theoretical yield is the answer provided by the stoichiometry, right? It's the scientific answer. It's assuming there's no error, but there's always error, right? So when you go in the lab, there's always error. We try to minimize it, okay? So let's apply that to this problem. And let's start over. We've got potassium chromate, K2CrO4, solid, plus silver nitrate, AgNO3, aqueous, yields potassium nitrate. We will need 2 of those. We need a 2 in front of the silver nitrate. And our silver, this is our aqueous, and then our solid silver chromate. So this would be a solid floating around in the solution. Like I said, we would need to filter this solid out. We would need to rinse it to get any excess ions off of it. We would need to dry it to get the water out. Then we could weigh it. And we would weigh it several times to ensure that all the water has been removed. And we would know that because the mass would stop changing, right? Well, we have 0.500 grams. And we were told that in the experiment, the experimenter managed to obtain 0.455 grams. So that there, guys, is our actual yield. So if we can answer this question, and it needs to be in grams since our actual yield is grams, we can get, that will be our theoretical yield, okay? And then we can determine our percent yield. So let's just get started by doing our stoichiometry problem. Let's get a good color here. I really think this might be a good one. All right, we've got 0.500 grams of silver nitrate. We will need to convert those grams of silver nitrate to moles of silver nitrate. We will do that by, remember, all stoichiometry problems need a, hold on, we need its molar mass, 169.90. Okay, that's per 1 mole. We need moles so that we could use our mole ratio. Moles of what we have to moles of what we need. That's the silver chromate. We're left to assume that the potassium chromate is our limiting, is our excess reactant because we're not given an amount of it. And I need to fix this. I need to write moles up there. We're going to moles of silver, or question mark, that's silver chromate. I apologize. Look up, our ratio here is 2 to 1. And now we need to convert our moles of silver chromate back into grams of silver chromate. All right. The molar mass of silver chromate, I have it written down over here, is 331.70. I'm assuming it's a 0 after it because I didn't write anything. All right, let's do the math, right? We need to do 0.5 times 331.7 divided by parentheses 169.9 times 2 equals, that should give us 0.488 grams. Grams of what? Silver chromate. And this, guys, is our theoretical yield, right? When you yield something, you get it. So theoretically, if we were to use the 0.55 grams and take it to the lab, we should end up with 0.488 grams of the other substance. Our percent yield, based on the question's data, said that the student or the experimenter actually got 0.455 grams. So the actual, notice, it's just a little bit less. So you can think about it this way, guys. It was like a test. You should have scored this many points. That was your maximum, but you actually scored this many points. So what was your percentage grade? What was your percentage yield? And you did a pretty good job. You got a 93.2% yield. And that's all you got to do there, right?